Howdy folks. Today we are going to be taking a look at Leetcode Problem number 9, Palindrome Number. I've covered this a couple times in class, but I haven't done an actual video on it, so I wanted to do that and show people just what it looks like. So let's take a look at what we have here. Given an integer, x, return true if x is a palindrome and false otherwise. They give us an example. If x is 121, then the output is true because 121 is a palindrome, is a palindromic number. And by that, they mean the digits are in a palindrome. So if you don't know what a palindrome is, basically a palindrome is it reads the same way backwards to forwards. If I were to flip this number around completely, it would still be 121, as they said in the explanation. Example 2, x equals 121, negative 121, sorry, and that is false because from left to right, it reads negative 121. From right to left, it becomes 121 negative, therefore it is not a palindrome. What that tells us something kind of valuable. That tells us that the negative sign counts towards it. Example 3, x is 10, that is false because it reads 0, 1 from the right and from the right to left and 1, 0 from the left to right. So it's not a palindrome. There's a couple of pieces here, okay? So let's go into our toolbox and let's take a look at how we would handle this. All right, just adjusting my volume a little bit there. So we've got two problems. We need to make something that can determine if something is a palindrome. But then we also need to apply that to a number. We don't know how to apply a palindrome thing to a number right now. But let's take a look. Let's figure out if we can just figure out how to figure out if something's a palindrome, because that comes up a lot, right? It comes up a lot and it is the first step. So let's see what we can come up with. Okay, so what I've done is I've left the Leetcode editor for now. The reason is I want to be able to try out a couple solutions and write some code without having to run it through the Leetcode stuff. So let's see what we get here. We want to have something that determines if something else is a palindrome, right? And we want that something to be immediately move aroundable, put it in various places, make it so that we can reuse it. We want a function, and generally it's a good idea whenever you're creating a tiny little block of code like this to wrap it in a function. All right, so I'm just going to start out by creating a function. So function, start off with the function keyword, is palindrome. Oops. Palindrome. Name. Does this take in any parameters? Well, let's think about that. If we're checking if something's a palindrome, we need to have something to check it against, right? So we need to actually have an argument that is the string we're checking. So I'm going to add a single parameter, string to check, okay? And then a pair of curly braces to finish out the function. Now we have a function. Function is palindrome string to check. Perfect. And now we got to think, what do we need to do here? Well, if it's a palindrome, there's a couple ways of figuring that out. But generally, let's just take a look at what is a palindrome. A real famous one is race car. That actually doesn't seem big enough. Let's zoom that in again. So race car is a valid palindrome because let's say if I was to do it backwards, we start with the R, A, C, E, and then we're here, right? C, we have the A here, and we have the R. It is the same forwards and backwards. You can see you don't even know if you're just looking at this whether I wrote it forwards and backwards. Race car is a palindrome. If we look at something like elephant, okay, and we spell that backwards, we start with T, N, A, H, P, E, L, E. Very clearly not a palindrome because it is not spelled the same way forwards as backwards. All right. So with that in mind, we can kind of think, if I'm looking at a palindrome and I need to determine something is a palindrome, how do I do it? How do I figure out that it's not palindrome? Well, let's see if I started out with one of my favorite palindromes because it's really short, ABBA. If I want to check and see if it's a palindrome, what I'm going to do is I'm going to look at the first half and I'm going to see if it mirrors the second half, right? Same thing with race car. If I copy this car, I can see that C there matches, that A there matches, oops, that A there matches as well, and then the R matches. Okay, race car. It all matches. But what I'm doing is a couple things. So this is for an odd numbered letter or odd numbered word. For even numbered words, it's a little different. But what I'm doing for an odd numbered word is I'm just ignoring the E in the middle. Because it doesn't matter what the E is. It really doesn't. It could be any character and it would still be a palindrome because the middle character doesn't have anything to mirror itself onto. All the other characters, however, do matter. So really what I'm doing is I'm looking at this first character and I'm seeing, does that match on the end? Then I look at the second character and I say, well, is that the second from the end? And if I look at the third character, I say, is that the third from the end? That's a pattern. I'm saying, okay, for each character, I'm looking at the character, and then I'm looking at the character on the other end, and I'm going to see what that does. So really, what I could do is, potentially, I could loop through this string and check each item against its corresponding position. Right? So if I'm looking, like, let's say if I look at the elephant example, right? I start off with first position. The 0 position is E, okay? So then I'm going to look at the last position, which is T. Those don't match. Okay, I immediately know it's not palindrome. I don't need to check any further. I can know it's not palindrome just by looking at those first pair of characters. The race car, on the other hand, let's say, okay, so I'm looking at R, all right? And the last character is R. Very cool, it matches. So then I bump this up. Okay, so the next character is A. But I also need to go back a character here. So I'm looking at second to last. Right? And that's also A. Cool. Then I'm looking at the third character. And then I'm also going to look at like last minus 2. Because the last is R, and going back 2, I get that character there. This character at position 2, because remember strings are 0 indexed, so the R is at 0, the A is at 1, and the C is at 2. Now I go to the very end of it and I say, okay, we've got R, that's our last position. Then we've got last minus 1, which is A, last minus 2, which is C. Okay, those all match so far. And then I've got my E in the middle. I don't care about E. E doesn't have anything to match to. This is a palindrome. So that gives me a little bit of an algorithm. Basically, I can say, okay, for every, if I have 0, right, then that should equal the last. If I have 1, that should equal last minus 1. If I have 2, that should equal last minus 2. Notice that these are the same. This 1 and this 1 and this 2 and this 2. That means we can generalize. And we can say for every n character, should equal the last minus n. That's a pattern, right? 0 becomes last minus 0, technically, to fit that pattern. And so now we have 0 matching last minus 0, 1, which is that A, matching last minus 1, and C matching last minus 2. If we had a longer string, we would keep going with that 3, 4, 5. So how did I get to this point? Let's just recap that for a bit. I got here by looking and thinking, let me figure out how I would do this. How do I, as a human, figure out this problem? I know if something's a palindrome because I understand what a palindrome is. If you don't understand what a palindrome is, that's the first step. Understand what the palindrome is, what it means, look at the examples. How do I figure it out? And then once I figured out how I figure out if it's a palindrome, then I distilled that into an algorithm. And I started guessing, okay, how can I make it so that this way that I'm figuring out this algorithm, I know how to do that. How do I write that down? And you could even write it down in plain English if you want. You could say, or whatever language you're most comfortable with. You could say, basically, to figure out if something is a palindrome, I look at the first character and compare it to the last, and if they are not the same, it's not a palindrome. Then I move to the next set of characters and do the same thing. On and on until I reach the middle. If you were to tell, basically, if I was to tell someone how to figure out if something is a palindrome, could I give them this instructions here? Is this human instructions? Can I give this to a human and tell them, here's how you figure out if something is a palindrome? Maybe I could embellish it a little bit better, just a little bit, but this isn't too bad. Then you slowly basically say, okay, what does that mean? How can I set up a formula for this? And so here's my formula. I started looking at what am I actually doing when I'm looking at my first character? What am I actually doing when I'm looking at the last character, or the next character and the second one? And after 3, I could immediately see there's a pattern there. And then so that I derived our n equals last minus n. This is our formula for figuring out if something is a palindrome. We basically loop over this. So really, if you want to take the 0, 1, 2, that's a loop, right? So I could say, all right, loop from 0 to 2. And then inside that loop, if a character, let's say as n, right? That's understandable, right? Loop from 0 to 2 is n. This looks enough like a for loop. And you can see why I'm getting 0 to 2, right? Because 0 to 2, that's how many characters I need to go over. If a character at n is not equal to character at last minus n, then it's not a palindrome. This is a lot more convoluted than our nice sentence here, right? Our sentence here is in plain English. It tells you exactly what you need to do. It's a very clear formula. We get down to here, well, now we've got some other programming terms in here. But you know what a loop is. You kind of understand this if statement, right? If character at n, I mean, I could even put it in quotes if it's not, is not equal to character at last minus n. That's basically what this is doing, right? I need to verify that all of these are true, because if any of these are false, then it's not a palindrome. If the character at 0 is not the same as the character at last minus 0, it's not a palindrome. Same with if the character at 1 is not the same as the character at last minus 1. I could say is equal to, then it might be a palindrome. We have to keep going. Otherwise, it's not a palindrome. That might be a clearer way to see it. If the character at n is equal to the character at last minus n, we pass the check. We keep going. Otherwise, if we fail the check, it's not a palindrome. So let's look at another way we can do this, all right? Loop from 0 to 2 as n. I'm not changing that. If, okay, I'm going to make this a little bit different, okay? String, well, let's do this. Character at n equals character at last minus n. Then continue, okay? Else return false. Very tiny step. Little bit more confusing. We've still got our loop, Okay, from 0 to 2 is n. We still know where 0 came from. We still know where 2 came from. This if is very similar to this if. It's just now we're using a double equals instead of the is equal to. It takes up a little less room than continue. What does continue do? Continue basically just says, hey, we're not breaking out of this loop. We're just moving on. We have to keep going. We have to continue on in the loop. Otherwise, return false. It's not a palindrome. It's not a palindrome means we return false because the whole thing that we're checking here is whether or not it's a palindrome. So if it's not a palindrome, return false. Okay, let's take another step. All right. Loop from 0 to 2 as n. Okay. Well, let's add a string into the mix now. Okay. Input string, or let's see, possible palindrome as a string. Okay. So now I'm going to change this just a little bit. I'm actually going to copy all this. Well, no, I'll just type it out. If, and now rather than character at n, we're going to say string n. Not too crazy, right? String n, this is basically the same thing as character at n. This is the character in the string at position n. That's basically what we're doing here, which is the same as what we're doing up here. If character at n is equal to character at last minus n, okay, if string n equals string at last minus n, okay, then what are we going to do? Pretty much the same thing here. I'm going to get rid of the then, or though. Continue, because continue is a valid JavaScript keyword. Else, well, this doesn't need to change. Return false, that's pretty much the same thing. So now we're like, okay, loop from 0 to 2 as n. If string n equals string last minus n, continue, go on. This is basically the same as our previous one here, except instead of calling it character at n, we're using the appropriate string notation to get our string bracket n. Strings act like arrays in JavaScript. You can index them and pull out characters using the square bracket notation, which is what we're doing here. This means the character in string, actually, realizing I called it possible palindrome, not string. So I'm just going to change that there. If the character in possible palindrome at n is equal to the character in possible palindrome at last minus n, then continue. We haven't determined it's not palindrome yet. Now remember, we derived that from here. That's basically this statement here. And that comes from what we got here. So we figured out our formula, n equals last minus n, wrote up what that actually means in English, okay, and then we're slowly turning it into something that's more JavaScripty. Let's go another step. Let's look at our loop. This is not a very JavaScripty loop. How do we do loops in JavaScript? Well, there's a couple ways. There's a while loop, there's a do while loop, and there's a for loop. Now, while loops and do while loops are generally, they're what we want to use if we don't have a good end condition. If we're not completely sure when we're going to stop the loop, we use a while loop. For loops are when we do know and we have a very specific case of when we're going to stop that loop. From 0 to 2, we know how long that loop's going to run. 0, 1, and 2. It's 3 runs. We could do this in a while loop, but it would be more complicated. Because we know where our start and end are going to be, at the time the loop starts, we can use a for loop. So I'm going to grab this, well, I'm going to say we have our input again. Possible palindrome is kind of long, right? I kind of want to just call it something like maybe like possible palin. Possible palin? No, I don't like that. That's a kind of a long word. Well, maybe we'll stick with it. We know exactly, it's a very clear variable because we know exactly what it is. It's something that could be a palindrome, right? So possible palindrome as a string. That's important. We need to know that it is a string. Now let's do our loop. For Okay. Now, what are the three parts of a for loop? We know there's the first one is the initialization phase, okay, where we initialize a variable that's going to be used as our loop counter. Here we're using n, so I'm just going to keep it here. N equals 0. Loop from 0 to 2 as n. That becomes for n equals 0, semicolon. What's our end case? When do we end? Well, we end when n is equal to 2, okay? So we basically want to say we're looping while n is less than or equal to 2. And then we increment n the entire way. These three statements are a very standard for loop. N equals starting case, less than or equal to the end case, increment. Okay? If possible palindrome, bracket n, this is not changing yet, possible palindrome last minus n, okay, then we're going to continue. Otherwise, and see, none of this is changing. Return false. This looks like JavaScript now. This is actually an algorithm that we could use, right? Very, very close to real JavaScript code. And you see how we got there. We started out just saying with a little bit of structure what we actually want to do. Loop from 0 to 2 is n. If character at n is equal to character at last minus n, which again we got from here, then it might be a palindrome. We have to keep going. Otherwise, it's not a palindrome. We changed that into a couple things, made it slowly a little bit more JavaScripty. If you ever get to the point where you do some change like this and you no longer recognize your code, go back to your previous one and see, do you still understand what you did here? Okay, then these are incremental steps. You can make them a little bit at a time, as tiny as you want. All right. Now we get down here. We've got our input. We're using that string instead. Now we get down here. We've got our for loop that's in there correctly. So what's the next step? Taking our input, palindrome as a string. Okay. Now what I'm going to do is I'm actually going to wrap my for loop in parentheses, because that's how we do a regular JavaScript for loop, right? And then I'm going to put a let n equals 0, because that's how we do variable declarations. Less than or equal to n plus plus, okay? And I'm going to do the same thing for my if statement. So if parenthesis, because in if statements in JavaScript we need to have parenthesis, possible palindrome character n, so we're still getting the nth character of possible palindrome. That has not changed. So the thing to bear in mind here, the algorithm, what I am still doing here is still this same algorithm here. These initial cases of what we're doing here have not changed. What has changed is how I'm representing them. So let's finish this up. Possible palindrome last minus n. Okay. Then we're going to put continue. And then we're going to put else. And then we're going to return false. Again, not too much difference from the above one. We just added parenthesis. Looks a lot more JavaScripty, doesn't it? In fact, here's a hint. This is actually valid JavaScript code, these lines. Completely legitimate. This is valid. This will run. There's a couple things we want to do to tighten it up. So what are those things? Well, first of all, what is last? Last doesn't exist. When we defined it all the way up here, we defined last as kind of the last character in the string, right? So we got last character in the string minus 0, minus 1, minus 2, minus n. So this is really the last character in that string. Last minus n. So if we really want to look at last, let's say we look at let's look at race car. What is the last character? What is the index of the last character in this string? So we start off with 0. Okay, that's R. 1, 2, 3, 4, 5, 6. So the last in this case is going to be 6, which means for the 0th index, we need to look at index 1 versus index 6. Then here we're looking at index 1, or sorry, index 0 and index 6. Here we're looking at index 1 mapping with 6 minus 1, so 5, 2, and 4. So let's just do this. Let's say 6, 5, 4, and the next one, right, would be 3, etc. So this goes down, this goes up. Another important thing, race car is 7 characters long. The last index is going to be 6. If you're looking for the last index of a string, it is always going to be the length of that string minus 1. Okay, so let me just show you. 0, 1, 2, 3, 4, 5, 6. Okay, let's put up another string. Happy. 0, 1, 2, 3, 4. Happy is a 5-length, 5-character string. H, A, P, P, Y. 5 characters. And its last index is 4. The last index of any string, or array for that matter, is going to be its length minus 1. With that in mind, let's come back down here, all the way through algorithms to the last algorithm. We have our input, okay, possible palindrome as a string. That hasn't changed. We will change that eventually. But now we can actually declare our last. It is going to be length of possible palindrome minus 1. Oops, not equals 1, minus 1. So that is going to be our last. Length of possible palindrome minus 1. Because the last index in any or of a string is always going to be the length of that string minus 1. Let's take a look at our for loop now. We're going to write it out. For let n equals 0, n less than or equal to 2, okay, n plus plus, and I'm actually going to put some curly braces around it too. That's okay. And I'm going to end those curly braces because, you know, for loop, we want to have things inside of it. We're going to put our if possible. I did it as palindrome up here. Palindrome of n needs to equal possible palindrome of last minus n. We don't need to change this. Why? Because we defined last. We defined it up here. We know what it is, so it exists as a variable, so we can use it in this statement now. I'm also going to put some curly braces here. They're not necessarily required, but it's just, I find it to be good hygiene, okay? We're still going to continue. That has not changed. We're going to put our else, and I'm going to put some curly braces on that as well. Just because it just looks better to me. Return false. And I want one thing at the end here. My for loop, right? Let n equals 0, etc. If I get through this whole for loop and everything's good, well, then I've found a palindrome. So I'm going to return true at the very end. I found a palindrome, and if false means it's not a palindrome, well, true must mean that it is a palindrome, right? So here we have, this is actually legitimate JavaScript now. Well, except for this line here. So let's fix that. Okay, we got to fix two things also. If we've got possible palindrome, this 2 is only going to work if something is 7 characters or 6 characters long. If all of a sudden we have something that's 10 characters long, well, we need to check 5 characters then. And this 2 just isn't going to cut it. So let's talk about that. What is that 2? Well, if we scroll all the way up here, that 2 came from the fact that we're using race car as our example. And we only went 0, 1, 2. We only need to check 3 characters for it. R, A, and C. How do we determine then how many characters we need to check? Well, for an even number, let's see. If we have even numbers, for this, we need to check 2 characters. How do we know that? Because we got the A, and we've got the B, and once we get to the B, we're out of characters. We're done. If I change this a little bit more, this is still 2. Okay? Because I've got the A, then I've got the B, and then when I get to the C doesn't have anything to match with, and so we're done. So let's take a look at the length of this. This one is a 4-character word, and we need to check 2 characters. This is a 5-character word, and we need to check 2 characters. Race car is a 7-character word, and we need to check 3 characters. Let's do something with maybe 10 characters, okay? Let's see if I can come up with some. What is elephant? How many does that have? That probably has 8. It does have 8. Well, let's see. How many do we need to check with elephant? Well, we need to check the T against the E, so that's 1. The N against the L, that's 2. The A against the E, and the P against the H, so that's 4. So we have 8. This goes to 4. Are you sensing the pattern yet? There is a pattern here. And that pattern, so if I was to tell you, okay, I need you to check this, well, you know it's 1, right? 1. The number of characters that you need to look over is equal to half of the characters in the string. Which kind of makes sense, right? Because let's say we're looking at ABBA. If we only check this first character and the second character, we don't need to check the others, because let's say we start checking this third character here, we'd be checking it against the first B. So we'd be checking position 3 against position 1. Or rather, position 2 against position 1. We basically check one half and then we check the other half. Let me see if I can draw that out in a way that might be a little less confusing. All right. Paint is amazing, you know. It really is one of the best things ever. So, if we're checking, okay, these things, we got to check A against A. So we're going to do, that is not thick enough. Let's see, can I make that? There we go. A against A. So we're going to check this, okay. And then the next one we're going to check is we're going to check B against B. But let's say we didn't stop there. Let's say we moved on to this B here. Well, what would we check it again? We flipped over the midway point, so we're going to check it against this B. Right? And then we go to the A, and we check it against this A. But we don't need to do that, because we already did that check. We did it when we came through the first half of the string. This check is the same as this check because they're the same characters in the same positions. They're just flipped in the order in which we're pulling them out. We don't need that. We only need to go through half of these. So once we get to this line here, we can just stop because we know any check that we need to do after that point is going to be a check that we already made. So once we get to that halfway point, we can stop. Well, what happens if we have something that is multiple? Or, sorry, odd. So A, oops, I don't want that. C, B, A, right? So that example, still a good example. All right, so let's see. We start off checking our A. Okay, then we check our B. And then we get to C. And we say, okay, what does C check against? Well, technically, this one is, this is 0, 1, 2, 3, 4. Okay. 0 maps to 4. We increment this and we decrement this. 1 maps to 3. We increment and we decrement, and then we've just got 2. So we're actually comparing C against itself, which is just silly, because obviously C is going to be equal to itself. So in this case, if we actually split this in 2 again, okay, and take and go fall on the left side, we know that we don't need to check B against B and A against A because we've checked them, right? We know that here. And we don't need to check C at all. So we don't need to do these checks. And that's why. So remember this, right? we don't need to check anything after that midpoint. And we don't need to check the midpoint either if it's an odd number. So we come here. That's why if you have that 5, it goes to 2. So what we're really doing is we take the length of the string, we divide it by 2. Now in the case of ABCBA, this one, that's actually going to be, if I divide by 2, that's going to be 2.5. And then we chop off the decimal point, which goes to 2, and then that gets our number of characters. Same thing with 7 here. 7 divided by 2 is 3.5. We chop off the decimal point, we get 3. So the number, oops, that's in caps. The number of characters we need to run over is length of string divided by 2, remove any decimals. All right? Length of string divided by 2, remove decimals. This is our way of figuring out how many characters we need to run over. I'm going to copy this, okay? And I'm going to go back down to my final algorithm here. N less than equal to 2. Let's do this just as a step. Const max equals 2, okay? And then I'm going to put max in here. That's a really small change, right? Makes absolutely no difference on what we're doing. We just put it into a variable, and then we put it here. Okay. Now I'm going to replace max with this string. Number of characters we need to run over is length of string divided by 2, remove any decimals. So if I get rid of this, max equals length of string divided by 2, remove any decimals. Okay? So how do we do that? How do we get the length of the string? Well, and this actually would be length of possible palindrome, because that is the string that we're looking over. Remove any decimals. To get the length of a string, it's basically just that variable dot length. So I can replace length of possible palindrome with possible palindrome dot length. And I can do that here as well. Dot length. There we go. Now we have our last, same thing. It's possible palindrome dot length minus 1. How do we know that? Well, length is a property of the string. If we want to access properties of the string, we use the dot. So we have the name of the variable that holds that string, possible palindrome. We have the dot, okay, and then we have the property that we want to access out. And that's what gets us the length of that string. Now we have our max, possible palindrome dot length divided by 2. Remove any decimals. How do we remove decimals? Well, there's a couple ways we can go about it. The most common, and this is something that you'll probably want to memorize, there are a couple of functions called math functions. And let's scroll a little bit up here to talk about those. Let's say we have a number, 2.5, right? If we want to remove the decimal, we have a couple options. We have math.floor, math.ceil, which is short for ceiling, and math.round. Math is a JavaScript standard library that is available. In other languages, you might just have floor, ceiling, and round available. JavaScript puts them under the math object. So if we want to access them, we have to say math dot, because floor belongs to the math object, and then floor. These are all functions. And let me show you what they do. If I say math.floor 2.5, well, the idea with a floor is like, let's say I have a number here kind of hovering 2.5, it's in the middle. Floor pushes it down to the floor. So this is going to equal 2. Math.ceiling, on the other hand, if I have a number hovering here, it's going to push it up to the ceiling. So math.ceiling to 2.5 equals 3. Round does something a little special. Round basically says, so let me show you. This 2.5 is actually also going to be 3. But if I did math.round 2.4, it would equal 2. So round kind of takes a difference in between the two. It says anything less than 0.5 goes down to the nearest whole number. Anything above 0.5 goes up. 0.5, they just had to make a decision on where that goes, and they just decided to make it go up. So 2.5 goes up to 3. Looking at these, this one brings it down to the nearest integer. This one brings it up, and so does round kind of does in the middle. If we look at our numbers here, if we have 2.5, we want to bring it to 2. That kind of looks like floor. And in fact, floor is a very common way of removing a decimal point, because that's what it'll basically do. It leaves the integer part, this part before the decimal, absolutely the same, and removes the part after. So I'm going to use math.floor. This is my way of cutting off the decimal point. So if I want to remove any decimals, I can't just put it like this, right? Because math.floor is a function that takes in something and returns that number without decimals. So I'm going to wrap my code in that. So now I'm saying, okay, give me the possible palindrome length divided by 2. Pass that into math.floor, which will remove the decimal, and that is my max number. Great. Now I've got our max. This code may actually work. So what I'm going to do is I'm going to copy this, okay? I'm going to come all the way back up to my original function here. Paste it in. And I'm going to get rid of these comments. Oops. And so now, kind of looks like a mess. If I hit Windows Shift A, oops, not that. Command Shift A, sorry. So, or Control Shift A for Windows. And I'm going to say reindent lines. And what that's going to do is that's just going to make it all nice and pretty. Well, now I have a problem. I named this originally string to check. And possible palindrome is what I built my algorithm with. I'm going to select that. And you notice when I select it, it selects all the others. So I know that I typed them all incorrectly. Copy that. I'm going to select string to check. And I'm just going to paste. There is our isPalindrome function. And we got here over a couple of iterations of what we call pseudocode. All these things that we looked at down here, this isn't really code, right? This is not something that you could run in a compiler or interpreter. JavaScript won't run this. Python won't run this. As we started going down, this is the first point where we got something that actually was true JavaScript. Then we added a little bit more, and here's our final. Pseudocode is an excellent tool for rapidly sketching out what you're doing. You write the pseudocode out of, basically you're kind of describing the algorithm to yourself, how you as a human would go through it. You don't have to use JavaScript keywords. As long as it's structured and kind of, I would do this, then I will do this, then I'll do this, then I'll do this. Write that out, and that can be really helpful for you figuring out how your algorithm actually works. Okay, so now let's test this. Okay, console.log. So I'm going to use console log. Basically, that's because I want it to print out to the console true or false. Okay, so I'm going to say, race car equals, and then is palindrome race car. Let's see if I save that and I run this, temp.js. Let's see what comes up. I think it's going to come up true. If it doesn't, we have to debug. Oh, or it could crash because I'm in the wrong folder. That's not on our algorithm. That's on me. All right, race car equals true. Okay, let's just copy this whole line. Okay, so I'm going to select it, controller commit or flower C. And then I'm going to put on something that's not a palindrome. Elephant. We know elephant is not a palindrome. Elephant. Be sure to change it inside here as well as here. This is just output. This is the actual important string that we're passing into the function. I run it again. Elephant. Not a palindrome. Cool. So now we have our isPalindrome function. Okay, this is important. You're going to be asked if things are palindromes a lot in interviews. So remember how to very quickly figure out if something's a palindrome. Let's grab this, copy, right? And then I'm going to go back to Leetcode. We now have our isPalindrome here. I'm just going to paste this function here. Because this is their function that they have, I'm going to call isStringPalindrome. Okay? I'm just going to rename it a little bit. But this code should be the same. I'm just renaming this because otherwise it'd be overriding their name that's already there. Okay, so now we've gone on a nice little tangent, and we've got a palindrome function. This, we know, will determine whether something is a palindrome. Okay? Now we got to do it on a number. Thing is, I can't pass a number into here. Numbers do not have a length property. Numbers cannot be indexed like an array or a string. So, what am I to do? Well, this is where the second part of how to build these algorithms comes up. You have to look at what you have and what you need. So look at it as a series of steps, right? I've got my palindrome, so if I was to write this out as pseudocode, I would write it as somehow turn x into a string, pass that string into isString palindrome. The algorithms actually become quite a bit simpler now, right? Pass that string into isString palindrome, turn x into a string, etc. There's only 2 steps here, okay? And in fact, I can probably even just write, well, one of them. I can say result equals isString palindrome my converted string. That's that. That's this, right? The other great thing about pseudocode is it can actually become your comments of your algorithm too, which can be really helpful. Like you can see I'm doing that here. And then I'm just going to return result. Algorithm done. Except I still don't know how to do this. If I can get this x into a string, then I'm done. I'm finished. The algorithm is complete. So how do I do that? Well, there's a couple of ways actually. One of them, a very common one, is you can just do it as a template literal. So my converted string equals, and we're going to do it here, you can just do a template literal in x. That will turn it into a string. This is probably the simplest way that does the least code. There is also a toString method that you can call on an integer that will return the string representation of it, but this should be totally fine. So now turn x into a string, pass that string into isString palindrome, and then this would be the last step, return the result. And then we've got our isString palindrome, which we've already been over. This algorithm should work. Let's give it a try. Accepted. Case 1, 2, 3. Okay, that was true. Negative 121, false. And this 10 also gives false. Let's go ahead and submit this and just see if there's any other bugs that we may need to work out. All right, no. And in fact, that's a pretty efficient algorithm. Pretty decent on the memory as well. They accepted our submission. Let's go back here and now the next part of this, the most important part after you've got your algorithm done, what is the time complexity of this? Well, time complexity is based on big O notation usually, and where n is going to be the length of whatever you passed in. So if I say O of n, n is going to be x dot length. It's going to be the length of x, okay? So let's see, this particular thing, converting a string to a number actually might be O of n, because if you think about it, you have to go over each character of each digit in the number, process it, and turn it into a string. So this, I'm going to say this is probably O of n. This probably will take longer the bigger x is. So if x is 12 or x is 20,000, this is probably going to take longer. isString palindrome. Well, let's take a look at that. Let's look in here. Palindrome.length, this is what we call a constant time operation. The system automatically knows the length of the string. It doesn't have to look it up. It doesn't have to search over it because it's just storing that data. This should be O of 1, I think. Let's look it up. What is the runtime of JavaScript string length? I did room time. All right, someone asked, is JavaScript string length constant time? Okay. Strings are immutable in JavaScript. The length property does not need to be computed each time it is accessed. Okay. And then someone else says no. There are no runtime performance or guarantees. However, it can be expected to be accessible in constant time with no linear time length computation. That's the important part. It is expected to be accessible in constant time. Okay, that's what you're looking for. Constant time is O of 1. We love O of 1. O of 1 is great. Linear time is O of n. We're okay with that. So this one, we know length, fetching the length is a constant time operation, and subtraction is also constant time, so this is O of 1. This one as well, we know length is constant time. Division on it is going to be constant time. Floor is a mathematical operator and thus is also constant time. So we can say that is also O of 1. Now here's a loop. Here's a problem. Loops are almost never constant time. So we look inside our loop and we say, well, what is the O of this? What is it? Well, to know that, we have to know how many times it runs and kind of contextualize that to what our input was. We know it runs up to max. Okay? That max is going to be the length of the palindrome divided by 2. Now here's the fun thing. That's x.length because x, the string, is going to be x.length, and that's my converted string. So possible palindrome has the same length as x, which means that this is going to be x.length divided by 2, but x.length is n. So this is going to be n divided by 2. Let's do lowercase n because we have an uppercase one here. Okay, looking up an element. In JavaScript, looking up an element is constant time. So for both of these, this math is constant time, this lookup is constant time, and the comparison is constant time. So this is O of 1. Continue, else, return false, return true. These are also all O of 1. I'm not going to write them all out, but you can see they're not doing anything that would become more complex as the number got bigger. The loop would be more complex. If the number gets bigger, this gets bigger. So we add all these together. Okay, the O of 1s don't really count. We just kind of ignore them. We look at any place we're using n. So we say this palindrome overall is possible palindrome is n over 2 for its time complexity. So we're going to move that up here. We're going to say O n over 2. Return, as we saw with the return here, because we're not calling a function here, we're just returning a variable, that is also constant time, O of 1. So our is palindrome function, we're going to add these up again. O of n over 2, and O of 1. We ignore the O of 1 again because we don't care about constant time. So this becomes O of n plus n over 2, which basically equals O of, if this is 2 over 2n plus n 1 over 2n, right? This becomes, you have to do a little bit of simple math for this, except you don't. And I'll show you why in a minute. Let me actually pull this out into its own line just because it's getting a little long. That becomes O of 3 over 2n. Now here's the fun part. We don't care about this number. Yes, something that is 12n is going to be slower than something that is 2n, but we're more interested in the class of n. Is it n? Is it n squared? Is it n cubed? Is it log n? if I change n from 3 to 4, it doesn't really matter. If I change n from 1,000 to 10,000, this number is not going to make that big of a difference. So we just get rid of it. Which means if I have something like O of n plus n over 2, that I just get rid of that over 2. And that just becomes O of n plus n. And because I know that that's going to be 2n and the 2 gets dropped, anytime I see something like this, I just know it's going to, anytime I see a plus, I just ignore it. Pluses are not important. If I have n times n, that's a problem, and you will get that if you have a nested loop that is also looping over n. N times n becomes n squared. We care about that. And plus n becomes 2n. We don't care about that. All right? So that's how, if someone asks you what the runtime or time complexity of this algorithm is, you can tell them it is O of n. So that's basically how to do palindrome number. I know this is kind of a long one, and it took a while, but I definitely wanted to make sure that you understood in detail how we get these solutions, especially with palindromes, because for whatever reason, interviewers love palindromes. Don't know why, but we love palindromes. So I think because it's kind of an easy question to ask, and if you don't know the trick, it's a hard one to answer. So palindromes, remember how to do them. Remember this way. So how do we do this? First of all, we wrote out our algorithm in English. We kind of tried to figure out the formula of how we did it. We said, okay, how do we know how many characters to run over? Before we even wrote code on this, right? We really look at it and say, okay, how do I figure out all this stuff? And I guarantee you, if you do this and you run through this and do this and build your code this way, your interviewer will be impressed. Especially if you articulate why you're doing it and what you're doing. Interviewers are going to love this because they can really clearly follow and they can see your thought process is clear and concise. That's what they want to see. And then we got down here, we did some pseudocode. And we slowly, this pseudocode, this is the jump. But it's not too much of a jump from here. So basically, you may look at this thing and you say, oh my God, how do I turn this question into an algorithm? This is how, small steps, baby steps. Write it out in English. Slowly start to build the formulas of how you compute this in English. Then write some pseudocode for it. And slowly make that pseudocode a little bit more JavaScript-like as you go along, little bit by little, little by little. And then eventually, you'll get down to this point where you have actual code. And then, we're going to go all the way back up to the top here. We put it into our function. Now that we have this function can be used in other places. You notice when we got back to our Leetcode here, our actual function here was very simple because we'd already done most of the legwork on this line. That's an assumption. We made an assumption that we have this ability already, which made the rest of it very simple. One problem at a time. Tackle one problem at a time. You look, there's actually two problems here. Turn x into a string and figure out that string is a palindrome. We solved one, then we solved the other, and then we put them together. So, as always, I hope this was helpful, and I'll see you all next time.